Python is ideal for working with GIS or geographical information systems. Essentially, it can help you visualize changes over time on a particular landmass.
Hi everyone, welcome back. When we're looking at geographical information systems, essentially we're looking at the ability to see or view changes over time. Um, this is needed for agriculture, looking at the health of forests, as well as the level of deforestation, and also it could help with urban planning or also looking at the level of urbanization. And these are um, just a few of the benefits of using geographical information systems. And what I'd like to do today is just to show you give you a quick glimpse as to a functioning program. And it's going to have some fake data, but the principle is the same. And the idea is in upcoming sessions, I'm going to show you how you can integrate it with real data and from either Excel spreadsheets or basically just connect your data. You could use a database management software as well. And it will show you how you could get a visual perspective, which can help you in studies, projects for school, college, university, whatnot. So let's get started.
As always, I'll have links to this session in the for this episode. And what I wanted to show you here is first the application in progress. So this is a two-step, a little bit different from what you've seen so far. In this case, we would click on the tab that says basically the Python file that says generate the synthetic urban data. This one does not, again, it doesn't use real data. It's a little fictitious, um, and but it's going to give you a perspective of what this visual change is really all about. So we will run this first file, and then we will go to the next Python file, which is the urban change demo. And we're going to run this one. Now at the bottom where we have the terminal, this uses Flask. So Flask essentially is the what it will connect to, and it does it through a virtual through a local server. So we're just gonna click the link of this local server IP address and view the interactive map. And here we go. So here we have a map of LA, and essentially what is happening here is that uh, this project helps us to see how a city grows over time. Um, in this case, Los Angeles, and see the expansion and the expansion that we have here is from the year 2000 to 2022. It essentially uh, relies on a map for each year, which in the back end of things, which shows the areas. The idea is that it'll give you a visual representation. And if this was real data, you'd probably get a square that's somewhat smaller or a bit larger. And if we increase the years, so essentially what it shows is if we could visually in, if we could visualize the level of urbanization over time, this would pretty much in perspective. So basically, in perspective to the actual size of the city, this is what we would get. And we can appreciate that in this case, if the data was real, we would be able to appreciate that this is quite a change. And it would be the same thing with deforestation. We could see the level of deforestation, which would probably be the opposite of this. We could also use pixels that could show the actual urban area and see how it expands and contracts. So it would probably be small triangles. Um, but essentially, uh, this is what geographical information systems help with. In agriculture, for instance, you would be able to see different, um, essentially from satellite pictures, a farmer would be able to see their crops and the health of their crops based on um, different light spectrums, and it could tell them if their crops are sick, if they need more fertilizer, etc. Let's get back to the actual um, program. We'll shut that down. So in my GitHub pages, I have included a, a document that shows you basically the optimal phrase if you wanted to create it without using code, but you wanted to play around with the NLP and see how it could generate the code for you for this GIS project. It explains how it works from synthetic data generator. It explains about the essentially what the Flask web application does here, um, as well as the front-end interactive map, and it provides you with the steps of the installation steps. Essentially, it works with two things. It works with Flask, which is a great, it's a web server. Um, uh, it's a simple web server basically that allows you to share maps. And Flask essentially sends the corresponding GeoJSON map. So GeoJSON is something that I will also mention uh, a lot as we will get into other projects that are similar. GeoJSON is a popular file format for maps and for geographic data. So it has a few benefits. It is easy to read, uh, even though well, mostly because GeoJSON files are just text, and essentially both computers and people can read and edit them. And and it works with web maps. Basically, a lot of mapping tools and websites like leaflet.js, which we will integrate some more, understand the concept, well, basically the GeoJSON utility. Um, it allows it to make it simple to display maps in a browser, essentially. And GeoJSON is also flexible. It could show many kinds of places, place points, lines, shapes, or basically collections of areas in one file. And it's widely supported. Many geographic information systems and a lot of mapping programs um, make it easy to share the data. So that is pretty much it. I will have all these files in my GitHub page and the link in this YouTube episode. Um, Thanks for watching. I really do appreciate it, and I will see you next time. Bye.